Good morning, students. Today we are going to discuss the third module of the engineering syllabus. Third module of the engineering syllabus of second semester. Formation of partial differential equations. Before going to the module, I want to introduce the partial differential equations. In differential equations there are two types. One is ODE, ordinary differential equations, and another one is PDE. In this ODE, again linear and non-linear. Again in linear, first order, and in linear, second order or second and higher order. All these types were discussed earlier. Okay, ODE we have studied. Now we are going to study the PDE, partial differential equations. Then before starting with the partial differential equation, I would like to tell you about when does this ordinary derivative exist and when does this partial derivative exist and how to differentiate them. If a function y is equal to f of x is there, that means a dependent variable is depending on a single variable x, then there exist ordinary derivatives. Okay, ordinary derivatives like dy by dx, d square y by dx square, and so on. All these are known as ordinary derivatives. And when does this partial derivative exist? The functions or the dependent variable depends on two or more variables. Say for example, z is depending on x and y. Then there exist partial derivatives. That is dou z by dou x, dou z by dou y, partial derivative of z with respect to x, partial derivative of z with respect to y. Like that, z can be again differentiated partially with respect to x and dou square zy, dou x, dou y, dou square zy, dou y square. Like that, partial derivatives exist. I would like to give live example for ordinary differentiation and partial differentiation. Say for example, area of a circle. Area of a circle A is equal to pi r square. If this is a radius r, then equal to pi r square. Here A is depending on single variable r. As the radius changes or increases or decreases, then its area has increased or decreased. Okay, its area has increased or decreased. In what ratio it has increased or decreased? To find out that, we are differentiating. That is change in area with respect to change in radius. That is dy dr is equal to pi is constant, differentiation of r square is 2r, that is 2 pi r. The rate change of area with respect to radius is nothing but with respect to perimeter it is changing. Whereas area of a right angle triangle, if you are considering area of a right angled triangle is given by A is equal to half B into H. Let me consider a right angle triangle. This is base, this is a height. In this case, there are two variables, both base and height. Area of this triangle is depending on base and height. If only base changes, increases or decreases, then this area is going to change, correct? Then we are finding the, by keeping height constant, we are changing into base, that is dou a by dou b is given by partial derivative of a with respect to base. Okay, that is how much it is changing, that is half into base differentiation. H is constant now, half h is constant, base b differentiation is 1. Like that, if you are keeping the height base constant, then if you are changing the height, increasing or decreasing the height, then also area changes. That is given by dou a by dou h, partial derivative of area to h, that is half of a base is constant, partial difference of h is 1. Okay, this is how the partial derivative exists, and there is a change in this. How I am going to relate this to the partial differential equation? Till now we know that differential equations containing these ordinary derivatives, it may be first order, second order or higher order, such differential equations are known as ordinary differential equations. Now the partial differential equation is nothing but a differential equations containing these partial derivatives are known as partial differential equations. In that also linear, non-linear, homogeneous, non-homogeneous, different type of partial differential equations are there. Before that, to deal with the solutions of partial differential equations, how to form the partial differential equations we have to discuss first. In formation of partial differential equations, there are two types. One type is if a differential equation is containing only the constants, arbitrary constants. Say here a, b are the arbitrary constants. Eliminating these arbitrary constants, we can form the differential equation. Sometimes z is depending on a function of x and y. Then that time you have to eliminate that function. Then you have to form the partial differential equations. So to begin with this one, formation of partial differential equations, first we would like to, throughout this module we are considering z is a function of x and y. Z is a function of x and y. Z is depending on x and y. Therefore the notations dou z by dou x, dou z by dou y, every time it is writing it is tedious. Therefore we are using the standard notations for them as dou z by dou x, partial derivative of z with respect to x, we denote it by small p, or zx, z suffix x. Dou z by dou y as q, that is zy. Dou square z by dou x square by r, second order partial derivative of z with respect to x, r or z xx. Dou square z by dou x dou y, that is denoted by s, zxy or zyx, or both are one and the same. Like that, dou square z by dou y square is denoted by t. Simple notations were used throughout this module. Now let me introduce the one or two examples on this formation of a partial differential equation. Let me form the partial differential equation for z is equal to ax plus by plus ab. Here a, b are the arbitrary constants. I have to eliminate them and I have to introduce the partial derivatives in this. And one thing we have to remember in this formation of PDE is, if the number of arbitrary constants here a and b and the independent variables are x and y, if a number of arbitrary constants is less than the number of independent variables, then we are going to get the partial differential equations of first order only. If the number of arbitrary constants is more than the independent variables, we have to go for second order or higher order. Today I will discuss only the first order partial differential equations. Now z is equal to ax plus by plus ab. I have to eliminate here ab. Let me differentiate this partially with respect to x. While differentiating partially with respect to x, I have to keep y constant. Therefore, dou z by dou x is equal to, I can write it as b. Differential of ax is a, by is 0, ab is also 0. Therefore, p equal to a. Then dou z by dou y, partially differentiating with respect to y, I will get dou z by dou y equal to q is equal to b, because ax is totally constant 0, b into the partial differential of z with respect to y is y, and it is also 0. Putting a is equal to p and b equal to q in the given differential equation, given equation, I will get z is equal to px plus qy plus pq. This is known as our partial differential equations to this given equation. Here we have eliminated AB. In spite of AB, I got P. P is nothing but dou z by dou x. Q is nothing but dou z by dou y. That is known as partial differential equation. Similarly, if z is equal to x plus a, here x plus a into y plus b. In the previous example, sum of the two terms are there. Here product of two terms is there. Then how to eliminate this a and b now? Now again differentiate partially with respect to x, dou z by dou x, that is equal to p, and here I have differentiating partially with respect to x. Now y plus b is constant, product of two terms is there, therefore y plus b is constant, and differential of x plus a is, partial differential x is 1, it is 0, therefore y plus p equal to y plus b. Similarly, differentiating partially with respect to y, I am get dou z by dou y equal to q, that is x plus a is constant and the differentiation of y plus b is 1. Substituting y plus b equal to p and x plus a equal to, in the given equation, p into y, p into q. This is my partial differential equation. Similarly, if addition of again two terms, if it is there, z is equal to x minus a the whole square plus y minus b the whole square, then how to form the differential equation? Differentiating again partially with respect to x, I am getting p, that is dou z by dou x equal to p, differential of x plus a the whole square, chain rule you have to apply here, therefore 2 into x plus a plus addition is there, separately I have to differentiate, therefore y minus b is 0, and here partial differential with respect to y, if you are doing, this is 0, y minus b is 2 times y minus b, then x minus a I can write it as p divided by 2, and y minus b I can write it as q divided by 2. Substituting in the differential equation, in the given equation, z is equal to p by 2 the whole square plus q by 2 the whole square. Taking LCM as the 2 square 4, shifting to other side, I will get p square plus q square is equal to 4z. This is my required partial differential equation. Let me write once again this one. P square plus q square equal to 4 times z. This is how to form the partial differential equation by eliminating arbitrary constants. In the next class, some more examples on this one only we will discuss with a second order, and then we will go for the formation of partial differential equation by eliminating arbitrary functions. Thank you.